Hello. So we are now going to question number 5. In this question, we consider three coefficients. Intentionally, I made up three coefficients to study like what happens if two of them are multicollinear. Then we want to study what happens to the other innocent variable. The answer is it has no problem. So, but for tractability, I intentionally make one of the variables as a constant variable, constant, and most of you have done well. But the conclusion is even if x1 is c, if x1 is c, then you cannot distinguish alpha 0 and beta 0, right? x1 is constant, multicollinear with constant. Then the question is what happens to x2? My answer is gamma is identified. There is no problem on gamma. That's the conclusion. That's what I want to say here. So this is yes, this is no. That's it can be tricky. So most of you have done well, but that's the some students just concluded that gamma 0 is not identified because full rank condition is violated. But have a look. Like, let me show you how it works. Basically, we are handling this kind of linear equations, simplest possible linear equations, and we change these two linear equations into matrix. 2 by 2 matrix with two unknowns, and constant c does not matter much. And now let's think about two examples. In one example, A is 1, 1, 0, 0, and on the other example, it's A prime is 1, 0, 0, 0. So in both cases, we know they are not invariable. The rank is not 2. Obvious. The determinant, if you calculate the determinant, both of them equal 0. So they are not invariable. So we cannot solve for both unknowns. However, it is clear that the first equation of A prime gives you x1 equals to c. So 1, 0, 0, 0. So it says x1 equals to c1. So the reason why it is not full rank is because x2 cannot be solved. So you are able to solve out x1 but not x2. Still, the full rank assumption is violated. Then, however, what's interesting here is from A, what you have is simply x1 plus x2 equals c1, right? So you only know x1 plus x2, but you don't know what is x1 and what is x2. You cannot separate them out. And how can you understand them? You can understand it as a matter of reparameterization. So when you are interested in x1 plus x2, this equation will help, right? But this equation will not help you at all. So if you are interested in x1 plus x2, then A works better than A prime. But if you are interested in x1, then A prime helps you better. So put it this way, I'm going to rewrite the equation, rewrite this equation by adding this and subtracting this, right? No difference, but the reason why I'm doing this is because I'm going to reparameterize the equation as, so this part, this will be denoted as y1, and this is y2. So I will change x1, x2 into y1, y2 using this relationship, so that I can rewrite the equation as same equation, but with different matrix, different unknowns. And then you have this, right? It's simple reparameterization. And from here, let's see what happens. It's mistake, 1, 1, 0, 0, 0, 0. So If you have 1100, then after the reparameterization, it becomes 1000. But the other guy becomes 1100. So the role has been changed. So this shows that you cannot identify one of them, but still you may be able to identify something which can be linear combination of multiple variables. That's that's what multicollinearity is, right? Multicollinearity, in multicollinearity, you cannot distinguish between x1 and x2. But depending on your situation, you may be even so the 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 theoretical description is the same. Multicollinearity implies the determinant is zero, or the matrix is not invariable, or matrix is singular. But in some cases, even in those cases, you may be able to identify something, or you may not. You may not be able to identify anything. So it depends. Like even like if there are multiple variables, it's not clear what you can identify and what you cannot. But simply saying that, like failure of full rank condition uh, does not allow you to identify anything. That is wrong. You may be able to identify something. That's what I wanted to say in this question, and most of you have done well. So also, it's algebraically very very annoying, but you guys do well. So I don't worry too much about that. And question 6, I think I don't need to explain more. I have explained it a lot in class. So, and I fixed, I commented if you are wrong in question 6. So I will be, I will be, I will skip question 6. So this is the end of the review for homework 1. When I receive homework number 2, then I'm going to review them soon. Also, I will review homework 3. So good luck.